All right, friends, here we go. We're going to take a look at this review. I'll probably do it in two parts because it's really super long and I'm making it before first hour. So I keep saying this, and you got to pay attention to these verbs, like know what it means to rewrite. The key to most of what we're learning is remembering that when you have base to a power equals an answer, it's the same statement as log base b of that answer equals the power. Going back and forth between those two is probably the biggest thing you need to know in order to be successful. So here I'm simply rewriting it. So if I'm starting with a log, I'll end with an exponent. And then here, if I'm starting with an exponent, I end with a log. So I start in the basement, I go get the power, and then I come back around and get the answer. Sorry. And it should be a true statement. Here, 16 to the 1/2, keep in mind that a half power is the same as the square root, equals 4. So the square root of 16 would be 4. Here, I start in the basement, I go get my power, and come back around and get the answer. And those are all things you could see on your yellow card and confirm that they are correct. So that is rewriting in the direction from logs to exponents. Now I'm going to rewrite it in log form. So it's telling you what your answer should look like right here. This is exponential, and this is log. Okay, so here, this would be log base e, but we write that as ln. And then the power always goes alone. So this giant number, which feels really unnecessary, would be on that side, and the 7 would go over here. So this one's log base 10, which is the common log, so I don't write the base 10. The power always goes alone, and then the 1,000 would have to go here. This one is log base 2, because the base is always the thing that's raised to the power, and then the power goes over here, so the 256 would go here. So that is just moving back and forth between these two forms up here, and that's definitely something you want to be able to do. Evaluate without using your calculator is going to be the yellow card. And so here, you think of it as an exponent. This is asking 8, because that's the base, to what power equals 1? Because we don't have equals power here. It doesn't tell us. So we are, and then you look, and then you think, okay, well, the power you would need to get a 1 would be 0, because anything to the 0 power is 1. Here, 2 is in the base. I do not know the power, but I'm trying to get an 8. I'd use my yellow card, see what power you need to go to get an 8, and the answer would be 3, because it's getting bigger. And then here in number 9, 5 to what power is 625? And so then my answer would be 5 squared, third. I feel like it's fourth. I wrote third on the answer key, but I feel like it's fourth. I also feel like I should get my calculator out. So, okay, then the next one is going to be, is going to be using a calculator to evaluate. Keep in mind that the root word of value is always number. So when you're evaluating, your answer should be a number answer. I'm just writing down the one that I did wrong on the key so I can make that correction. Sorry. Okay, so here, this is asking 10 to what power? Well, I'm going to enter this into my calculator as log of 110, close that parenthesis, and since the base is invisible, it must be a 10, and I'm going to get 2.041. This is ln, so it's base e. So I can actually just do, the calculator has an ln button, so I would do ln of 1/2, and I'm getting negative 0.693. This has a base, so I'll have to do log 12, close that, over log 7. So the number in the bottom stays in the bottom, and that I got 1.277. Same thing here. This is saying 5 to what power is 1.25? I have no idea. I'm going to close that down, put it over log 5, and I got 0.137. You should be trying these on your calculator. Make sure you know how to do this. So again, the log of the regular number, close that, over the log of the basement or bottom number. So the basement or bottom number stays on the bottom, and this one I got 2.018-ish. Okay, so that's on your calculator. Inverse was probably the hardest day for most people, and that's where we start by swapping the x and y. So I write the x where the y was, and then I write the y where the x was. Since this is starting as a log problem, it should end as a power problem. Now I need to get the y alone, so I'm going to switch to the other type, start in the basement, go get the power, and that equals y in this case. And so since I'm already have y alone, I'm done. Now you would have noticed I put a -1 power in my answers to show as the inverse, but you don't have to do that. So here, x equals ln y plus 7. I just swapped the x and y. And then I need the ln part alone, and then I'll be switching it to a power. Keep in mind, since my original problem has a +7, I expect to have a -7. And since this has a log base e, I expect to have a power base e. So my first move is to take away that 7. So now these are kind of working together. And then now I have the log. Whenever you're stuck with a log, change to a power. Stuck with a power, change to a log. So this has an invisible base e, so it would be e to the x minus 7 power, and then that would equal y. And since y is what I'm looking for, I am done. And I have the e base that I thought I would have, and I have the -7. Looking at this one, I have a +2 in the problem, so I expect to have a -2. And I also have log base 6, so I expect to have a power base 6. Put the x where the y was, and the y where the x was. And then, even though the y has a +2, it's in the parentheses, so I can't do anything about it. So I'm going to go ahead and switch to the other form. 6 to the x equals y plus 2, but I need y alone, so I take it away. So when I'm done, my y is going to equal 6 to the x minus 2, and I have the elements I expected. I have a -2 because I had a +2 before, and I have a power base 6 because I had a log base 6. Now these do not have a log, so I expect the answers to have a log. So there's that. And now I need to get that alone, and since I'm kind of stuck, I'm going to switch it to log form. So I'm going to write log, and the thing that is raised to the power is the base, so that's the 7. The power goes over here alone, meaning the x must fit here. And since y is alone, I'm done, and that's my inverse. Same thing, swap my x and y. Now this one has a -3 in the answer, so I'll have a +3. It has a base of 2, so I'll have a log base 2. I have to get the power part alone, and so I'm going to add the 3 on this one first. So x is now kind of partnered up with the +3. And now that I have the power part alone, I write it as a log. So 2 is raised to the power. That makes that the base. The power always goes on the other side. So that puts the x plus 3 here. Y is alone, so I am done. And again, this had a -3, I have a +3. This had a power base 2, I have a log base 2. So that's all good news. Here I'm going to have x equals 4, 2 to the y minus 6 when I swap. Now I need the power part alone, so I have to get rid of the 4, which is multiplied in. So I'm going to divide it out. So x over 4 equals 2 to the y minus 6 power. Now I have the power alone, I write it as a log. Log base 2, because that's what's raised to the power. Power goes over here alone. The power is always what's up high. That leaves the x over 4 to go here next to the log. I'm trying to get y completely alone, so I'm going to add 6. So in the end, I have log base 2 of x over 4, and then a plus 6 equals just y, and then I'm done. And when you're finished, you can always look and be like, hey, this had a -6, I have a +6. The original problem was multiplied by 4, I'm dividing by 4. This had a power of base 2, I have a log of base 2. So you are getting everything that you should get. So I'm going to stop there for part 1, and then I'll make another video for the other pages. Hope that helps.